Can someone tell me what we studied in the previous lab?
Decoder, encoder.
Sure.
Yes, sir.
And then what did we do with that?
Priority encoder.
Okay. And then we had an application for that, isn't it?
Yes, sir.
What was it?
That LED, sir. LED.
Good, good. So we tried looking into uh, the application part, okay, which is nothing but the LED display. So how many segments did it have? Yeah. Okay. Good. Disha says 7. Good. Okay.
7 segments, sir.
Yes. Good.
7.
So this is what we had seen in our uh, previous lab, isn't it? So where we used decoders, and then we used an application oriented as to how we will be displaying it, okay, and then we also looked into uh, the common anode part and the common cathode connections, right? Okay, just a moment. Right. So today we will be looking into a different experiment, okay, which is nothing but your flip-flops. I think it's a very well known uh, you know terminology. What's a flip-flop? Flip-flop? Is it something new? Flip-flop? What's a flip-flop? Bhumika, what is meant by flip-flop? Supreet?
Flip-flop
Sir,
is a sequential circuit, sir.
Okay,
it is used to store data.
okay, fine. So there are different good. There are different configurations here. Okay, so we'll be looking into master slave JK flip flop, T flip flop, and D flip flop. Okay, so yeah, so the IC number for your master slave JK flip flop. I think all of you know how this master slave flip flop works. Do you all? Do you all know how it works? Yes. So we have three configurations here. One is master slave JK flip flop, then we have T flip flop, and then D flip flop. Okay. So before we get into it, okay, first we will understand how your JK flip flop is, okay, and then we will understand how your T flip flop is, and then we will understand how your D flip flop works. Okay. Right. So I think all of you are able to see the screen. Initially, um, before we moved on to this concept, we had something called a gated D latch, right? And we also had the gated SR latch, right? Wherein we were looking at the clock signals and the input signals. Now here, the disadvantage of an SR latch, can someone tell me why we don't prefer using SR latch or SR flip-flop? Is there any disadvantage with SR flip-flop? Okay. So in your SR latch, okay, whenever there is a high value, when both S and R are high, okay, we get an unpredictable state. Okay, so it's an unstable state. So we are not sure if it's 1 or 0, or it will be an unstable state. So in order to rectify this issue, okay, what we did was we went with something called JK flip flop. Okay, so JK, that's the name of the scientist, which is Jack Kilby. And does someone know who is Jack Kilby?
No, sir.
Okay, he was a scientist who actually invented the IC. Okay, right. Uh, so we came out with a flip flop called JK flip flop. Now see here, this is the configuration of your SR flip flop. Okay, where the NAND gates, you have a set of NAND gates which are cross connected. I think all of you are aware with this configuration. Yes or no?
Yes, sir.
Yeah. Okay.
Yes, sir.
So here, if you can see, wherever there is 1, 1, okay, we have an invalid state. Okay, and wherever it is 0, okay, wherever it is 0, okay, then the output is 0. That's fine. So what we did was we took the configuration, okay, of something called JK flip flop. So here in JK flip flop, we are connecting one of the terminals. QN terminal is connected with K, and the QN bar is connected with J. The other two terminals, okay, one is called J and the other one is called K, and then a common clock. So as usual, it is cross coupled here. Okay, so with this configuration, even though we have 1, 1 state, okay, it's not going to hurt us. Okay, so you can see that, with 1, 1, with the excitation table, I think you are now very much aware with this characteristic table and excitation table, isn't it?
Yes, sir.
Yeah. Now, if you can see the D flip flop, the same configuration, the cross coupled configuration, and here clock, but then one of the input is complemented. Okay, one of the input terminals are complemented. Here separately we have J, K, and then one QN is connected along with K, okay, and then QN bar is connected with J's NAND gate. But here we just have a clock and then uh, a complemented. Here, say if it's 1, okay, then 0 will be connected here. So what's the specialty of a D flip flop? Whatever is given as your input, the same thing you can expect as your output, right? So for a T flip flop, we made certain configuration, same JK flip flop, but both J and K are shorted. Okay, J and K are shorted, and then just given one input, and that is T. Okay, so here you can see the truth table for your T flip flop. So whenever your T is 0, okay, whenever your T is 0, whatever is your output, okay, the same thing is continued, right? If in case your T becomes 1, okay, if in case your T is 1, whatever was your output Qn, okay, that gets changed, which means it gets toggled. Okay, so here you can see 0 is getting changed to 1, right? So here again 1 is getting changed to 0. Why is that happening? Because we have T is equal to what? 1. So I think you are clear with these concepts, isn't it? Yes or no?
Yes, sir.
Yeah. Right. So now we will discuss about the master slave flip flop. Okay, so just a moment, I will pull up that information for you. Fine. So here we have two configurations. Okay, which means we have two SR flip flops. One works as the master and the other one works as a slave. Okay. So ultimately, you should understand that both of them do not work at the same time. The reason is because they have an inverter here as clock. Okay. Now, whenever you enable a circuit, okay, it starts functioning. If you do not enable your circuit, will it function?
No, sir.
No. Okay. It's as good as giving food to your circuit, right? Okay. So let's say, for example, okay, your clock is 1 here. So if clock is 1 here, what's going to happen? You are going to get 0 here. So which means this 0 is fed here. So will this slave flip-flop be enabled if the clock is 0?
No, sir.
It will not be, right? So which means it is working like, if this functions, this wouldn't. Okay. If this is not functioning, then this would. Okay. So that is being enabled with the help of our inverter, right? Okay. So there are different cases to understand the operation. When 0 is given, 1 is given. Okay. So now let us take one state. Okay. So when I say one state, both j and k are equal to 1. Okay. Your j and k is equal to 1, and your clock is equal to 0. Clock is equal to 0. So which means if it is 0 here, I'm getting a 1, and 1 comes and sits here, right? So due to feedback, the output of J gate is 0. So which means the feedback is at Q bar here. Okay. So initially there was nothing. Okay. So due to the feedback, what is happening? You have 0 coming and sitting here. Okay. The output of K gate is 1. So obviously if this is 0, then this is going to be 1. So 1 is going to come here. So the output of this gate is going to be 1. If the clock is changed to C is equal to 1, then master is reset. Okay. Now say for example at this point of time, okay, now what I do is I change the value from 0, I change it to 1. So at this point of time, this becomes 0, and here also it becomes 0. So which means master is working, slave is not working. So at this point of time, the output of your J is 0, right? So you all know that, right? In a JK flip flop, whenever your J's output is 0, okay, whatever is fed, okay, so that becomes 0. And here I should be getting the 1. So which means we can say that the master is in what state? The master is in, if I'm getting a 0, it is what? Reset. Students, are you there with me?
Yes, sir.
Yeah. If I'm getting a 1, then I say that the flip-flop is in fact set. Now let us go to the next configuration. So in our next configuration, okay, we will assume 0 state. So what is this 0 state? C is equal to 0. Okay. Assume in 0 state, C is equal to 0. So assumptions are there, a lot of assumptions. So you should analyze things. Okay. C is equal to 0, J is equal to 1, K is equal to 1. We are assuming things. Okay. Due to feedback, the output of J gate is 1. Okay. So let us take this as 1. So which means this also becomes 1, 0, 0. So which means here 0. Okay. See, ultimately what you should understand is whenever it says a 0 state, okay, whenever it says a 0 state, the output Okay, the output is referring, the final output is referring to 0. Now in the previous one we saw when it is one state, what should be my Q? Q should be what?
0.
In one state, in one state previously we assumed that we checked that our Q was what? 1. Okay, so ultimately this one state and 0 state is talking about the final output of Q. Okay, so when I say 0 state, it means my Q is 0. So if my Q is 0, Q bar will be 1, right? So this 0 will come here, this 1 and 1 will come and sit here. So J is equal to 1. So what is going to be my output? My output will be 1. So when I say 1, then my master is what? Set. Okay, so whatever the values are here, okay, next when the clock goes 1, okay, after 0 when it goes 1, okay, and this goes 0 in the next clock cycle. Say if this is working at one clock cycle, this wouldn't work in the same clock cycle, but in the next clock cycle these values will be passed on to your slave. Understood? Whatever were there previously, in the next clock cycle these values will be passed to the slave. So first the values appear in the master and then it is passed on to the slave. Understood? Any doubts, students?
No, sir.
Okay, now let us go to the next case. Okay, now whenever there is a 1 on J input line, okay, 0 on K input line, so this sets the flip-flop. So we all agree with that, right? So whenever our J is equal to 1, okay, and whenever there is a 0, okay, then what happens? We can expect if it's a 1 state, right, or if it's a 0 state, let us say 0 state, then this is going to be in set. Okay, this will be in a set state. If one state unchanged, because SR is set to be 0, that we saw in the previous state. Now if it's in 0 state, that is this state, okay, if it's in 0 state, S is set to 1, okay, just like how we saw 1 and 0. So in 0 state, S is set to 1 and R is set to 0. So S is 1 and R is, this is 1 and this is 0. Okay. So what is your takeaway from this? The takeaway from this is that whatever values are there for master, those values are passed to the slave in the next clock cycle. Okay. So you should be knowing the truth table of your JK flip-flop. Right? So whenever J is 1, the output tends to be 1. Whenever J is 0, the output tends to be 0. Okay. Okay. So this is your total JK flip-flop. So internally, we actually have 1, 2, 3, 4, 4 NAND gates, just like we saw. And these are your pin numbers, J input, K input. Okay. And then you can give your you can get your Q and Q bar at pin number 15 and 14. Now, how will you verify this? Based on your truth table. Similarly, your T flip-flop, just like how I showed you, J and K both are shorted. Okay, we can use the same IC 7476 and we can short J and K and that becomes our T flip-flop. So in T flip-flop, what's the speciality? Whenever the value of T is 1, then the output is changed. If it is 0, then it becomes 1. So D flip-flop is something where we have an inverter. So for inverter, we use 7404. And for this JK, as usual, we use 7476. So in between, inverter is used. Okay, so which means true value will be here and the complemented value will be here. Okay, or say, for example, if I give a 0 here, then 1 will be here. So true and complemented will be. And the clock is given at pin number 1. Then whatever is your input, D input, the same thing you will get at your Q output. Okay. So, and of course, you know that your Q and Q bar are what? Complementary to each other, isn't it?
Yes, sir.
Yeah. So the final output you will get from pin number 15 and pin 14, right? So the only changes that you are doing is to the initial setup here. Okay. So if you connect an inverter in between, it becomes a D flip-flop. If you short them together, then this becomes a T flip-flop, right? If you give them separately, then as usual, we can use it as a JK flip-flop. So one IC, multiple flip-flops can be implemented. Okay. So that's about it for your experiment today. Okay. And I'll be also sharing in a video where you can actually check out how it is connected practically, and you can view the outputs. So students, any doubts till this concepts discussed?
No, sir.
Okay. So you'll be using a 7404, as you know, an inverter IC, and you'll be using a 7476, your master slave JK flip-flop. Okay. So only with these two, you can implement different configurations, and you can check your output. And these all are not new to you all, right? You have already seen this in your theory classes as well. D flip-flop, T flip-flop, JK, and you have even written it for your internals and assignments as well, right? Okay. So if there is any doubt, then we could have another meeting in some time. Okay. So can we end our meeting now?
Sir, one small doubt,
Yes.
sir.
Yes. Yes.
In
Tell.
this master slave JK flip flop, that 7476 IC,
Hmm, hmm.
inside that are there two SR flip flops, sir?
It will be there. Yeah. The NAND configuration. The NAND
Oh,
configuration which I showed you, cross coupling and all those things, those will be there. Okay. So in order to make things simple, okay, we normally use ready-made ICs. Okay. Even that can be done. You can take, see, instead of your inverter, just like how you're using 7404 inverter. So similarly, you can use an AND gate and then connect an AND gate, but then you'll have to know from what pin you'll be giving your input and from what pin you'll be taking your output, right? So which means you'll have to use an AND gate. You'll use, if you want to still get into simpler terms. If not, then NAND gate you can use directly, NAND IC, and do the cross coupling connections and then go ahead with it. So in order to make things still simpler, this IC is available, which is 7476, wherein directly you can just use the pins, and internally the connections will be there.
okay, sir.
Okay, fine.